Today we're going to have a presentation on the Prim and KRUSKA'S algorithm. We're going to begin with the minimum cost spanning tree. A minimum spanning tree, or with the acronym MST, is a subgraph of an undirected graph. Such that subgraph spans will include all the nodes that are connected in a cyclic and has the minimum total edge weight. As you can see from the illustration, we have a graph from the left side and a spanning tree from the right. We have some characteristics from the algorithm side. Prim and KRUSKA'S algorithm, they both work with undirected graphs. They also work with weighted and unweighted graphs. They are called greedy algorithms that will produce optimal solutions. The KRUSKA'S algorithm, it selects the shortest edge in a network. It selects the next shortest edge without repeat a cycle, and repeat the second step until all the vertices have been connected. Meanwhile, the Prim algorithm will select any vertex and select the shortest edge connected to that vertex. Also, we just select the shortest edge that is already connected to that vertex, and we have to repeat the third step until all the vertices have been connected. But let's begin with the KRUSKA'S algorithm. We have to work with edges instead of nodes and of graph. We have to sort edges by increasing edge weight. For example, don't forget that we have v minus 1, which will not generate a cycle. You can see from the graph illustration. Let's consider an undirected weight graph. We have some value there from the edge weight. We have to sort the edges by increasing the edge weight. As you can see, we have the values there from the two tables. So from D to E is 1, so we write the cost there, 1. From D to G is 2. Now, we don't have to go to D to C because 3, but we can directly go to E to G. Now, we create a cycle, which we don't want that. Let's go to C to D. G to H. C to F, while B to C, it's still good. Let's have another B to E. No, because B to E will create a cycle. B to F. No, because it will create a cycle. B to H. No. As you can see, we're the cycle. A to H. As you can see, if we did that, there would be no problem there. We would go to D to F. Would be a really mess because we create a cycle there. And that we have found a sum which is 21. But we don't have to consider D to F, A to B, A to F, because we already found the cycle that we need. Well, Prim algorithms work as the minimum spanning tree and greedy algorithm. Don't forget the values that we don't know. We write them with the infinite sign, while the pivot with the negative. As you can see from the illustration, you have a graph with some edge weight. You have to start with terminal V1. You can start from A to H, no problem there. So in this case, I have chosen D. D to H, we have A, F, F and G. So let's write other nodes, the value there. Let's connect to the G because it's the lowest value. If you go to the G, we would have to go from G to H or continue D to C, whatever choice you like. we write the values. In this case, I've chosen D to C. Don't forget that it's way better to choose the node that we have left behind than go forward. So we have to fill it full before we leave it empty. Yes, we choose it C to F. Write the values. Select the node with the minimum distance. Yes, of course, we have another node there. Yes, G to H. If you would go further, I think that we'll go to H to A. And now, it's way better go to A to B and we'll be over with the cycle. Now we're over with the graph. We have found the lowest values. And if you calculate them all, be a value there, we just find one. What was the difference between Prim and KRUSKAL algorithm? The difference between Prim's algorithm and KRUSKAL is a set of stacked edges will form a tree at all times when using Prim algorithm, while at first is formed when using KRUSKAL algorithm. The Prim one is the least cost edge. We use U and B as an argument there. We use with added to the T such that TU is also true. This will repeat until T contains n-1 edges. We have they both will always give solution the same length, of course. They will usually select edges in different order. Occasionally they use different edges. This may happen when you have to choose between edges with the same length. Yes, we are in the end. So don't forget about what we learned today. It was a really easy one. I preferably choose both because they are easy to use. Don't forget we use the grid algorithm, which mainly we use the least cost edge. We use only the minimum. And don't forget that Prim and KRUSKAL are really easy. Don't worry. If you didn't understand, write me down below in the comment, and I'll try to give my best to give an explanation to you. So thanks, and see you tomorrow with computer networks. Goodbye.